Hello, welcome to this video on finding the key features of radical functions. This is the start of Unit 7, and we're going to go ahead and look at functions involving square root functions and cube root functions, hence the term radical functions. So our objective for this lesson is to find the key features of radical functions, and this is lesson 7-1. For prior knowledge, go ahead, please pause the video, try this, see what you can remember from your memory on domain, range, and increasing, decreasing. Alright, hopefully you pause the video. We're looking at a rational function, and a rational function, if you can recall, has a couple of discontinuities. We have a vertical asymptote here, so that's one type of discontinuity, and that's going to affect the domain. The domain values are all real values, are x values such that x is less than 3, where the vertical asymptote is, or it could be x is greater than 3. All values, just not including 3. And as an interval, that would be negative infinity to 3, union 3, to infinity. Now range has the same idea. Again, remember range, we have all real values except for this discontinuity for the y values, which is the horizontal asymptote, and that's occurring at y equals 2. So the range would be the y values less than 2 or the y values greater than 2. And again, as an interval, negative infinity to 2, union 2 to infinity. Now lastly, increasing, decreasing. Remember, increasing is just if a function is going up from left to right. Decreasing is if a function is going down left to right. So looking at this function, and kind of helps just to drag a pencil across the function, we are going down from left to right. So this is a decreasing function. Alright, so let's go ahead and we're going to talk about the key features now relative to a radical function. And the first function that we're going to go ahead and look at is a square root function. So you can circle this one. This is a square root function. And it has a characteristic that it has one endpoint located here. And it has one end that will continue on forever. So this is a square root function, and we'll talk more about kind of why it just has one endpoint. But first, let's go ahead and talk about the domain and the range. Now, what I recommend for these functions is listing an ordered pair wherever that endpoint is. So here's the endpoint, and if we were to go ahead and make an ordered pair, this would be at 4, 5. 4, 5. Now, why is that important? Well, because that is an endpoint for our domain and our range. And if we're talking about domain values, the domain starts here at 4. We're including 4 because I do have a point at 4. And then all of the x values for this function continue on in this direction. Okay, and so if you're thinking about this also kind of like a number line, if I made a number line here and I just said, hey, here are my x values, here's 4, and my function's continuing in this direction, going towards positive infinity. You could say, for inequality notation, that this is x is greater than 4 and equal to 4, because I'm including that endpoint. So x is greater than or equal to 4. As far as set notation, it looks just like the number line here. That would be 4 including it, so I'm going to put a bracket, all the way to positive infinity. Now range is kind of the same idea, except instead of using our x values, we're going to look at our y values. And our y values start here at 5. Again, I'm including 5, and then the y values are going up. They're increasing, right? So like I have a y value here, that is 7. I have a y value here, that is 8. I have a y value here, that is 9. Albeit they're starting to go up really slowly, but eventually, right, they will reach positive infinity. So if I was to make another number line here, so y, and I placed 5 here, again, I'm including 5, and then all my y values are going up. They're going towards positive infinity. So the range is going to be y is greater than or equal to 5. And then as an interval notation, again, 5 to infinity. And I include 5. I have a point at 5, so I put a bracket, closed bracket. All right, so that is domain and range. Now we're going to go ahead and look at end behavior. And square root functions, like I said, they only have one end behavior. One end behavior. Again, this is for square root functions. Square root functions only have one end behavior, and it's wherever the arrow is. So you can see here in this direction, we're going to the right, and we're going up. Okay, well, we just now need to translate right and up again into mathematics. And remember, right, those are our x values. They're going to positive infinity, and then they're going up, our y values. So that's also towards positive infinity. Right, so right, positive, up, positive. So it's positive, positive. And we can go ahead and fill in our end behavior here. So as x goes to positive infinity, our function, I want to make sure this function, I call it by its name, g of x, g of x. G of x is going to positive infinity. And again, if you substitute out g of x, at least for my class, or for my student, if you call it y, that is accurate as well. Check with your teacher. All right, and then is this function, well actually, sorry, I want to go back to this space here. We have two spaces. Again, we're dealing with two types of functions. Our second function does have a second end behavior. Here we don't have a second end behavior for square root functions. So we'll just ignore that for now. And then is this function increasing or is it decreasing? Again, well, if we drag our pencil across it, kind of left to right, I don't know if this is left to right for you, it's left to right for me, but it is going up. So this is an increasing function. So I'll go ahead and circle increasing. And this function is always increasing or decreasing, right? But g here specifically is increasing. Okay, that is it for this example for a square root function. Here is example number 2 of another square root function. Again, it has this endpoint right here, and this endpoint is at, what do we got? -2, comma, -1. Okay, there's our endpoint, and then it continues off in this direction forever. So this is a square root function. I'll go ahead and circle the square root function question. And it's asking about our domain. Well, domain are x values, and our x values are starting here at -2. So if you like the number line, I'll place x, I'll put down -2, and then our x values, are they going to the right or to the left? Are they increasing or are they decreasing? Well, our x values are going to the right. I have an arrow going this way, and that's towards positive infinity. So for inequality notation, this is x is greater than or equal to -2. All of those x values, right, going this direction here, this is -1. This is 0. This is 1. This is 2. All of these x values are bigger than -2. So x is greater than or equal to -2. And then interval notation would be -2 to infinity. And we include -2 again, because I have a point there. All right, our range. Our range is the y values. So our y values start at -1. So again, I can make a number line. I'll place -1. And then our y values, are they going up or are they going down? Are the y values getting bigger or are they getting smaller? Well, I guess bigger in a negative direction. They are. So here, this is, -2. This one here is -3. This y value here is -4. So they're getting smaller, or they're decreasing, I should say. And they're going towards -infinity. Okay, so that would be all of the y values less than or equal to -1. -1 in this case is kind of like the ceiling. And then for interval notation, you can kind of look at your number line here. We go from negative infinity to negative 1. And a common question I get asked is, does order matter? Do I have to put the negative infinity first? Will it be fine if I put negative 1 first? The answer is it does matter in this case. Interval notation is always in order you have your lower bound to your upper bound. So negative infinity is your lowest value, right? That's definitely lower than negative 1, so you're going to put that one first. Okay. End behavior, again, we only have one, and that is over here at this arrow. We're going to the right again, but this time we're going down. So right, that's positive. Down, that's negative. So our end behavior is going to be as x goes to positive infinity, our y values, or g of x, goes to negative infinity. And the two examples I showed you were just x going to positive infinity. You can have an example where it goes the other direction, and we'll see that in this lesson. Okay, is this an increasing or a decreasing function? Well, as I go left to right, is it going up or down? And it's definitely going down, so this is a decreasing function. Left to right, up or down, decreasing. Okay, here is a practice problem. Again, if I'm going too fast, pause me. Pause me, get these notes, get all this down. If you have any questions, pause me, write it down. You can ask a neighbor or reach out to your teacher. Here is the next example. Go ahead, pause this video, and I will reveal the answers here in a second. All right, here is the solution. This is a square root function, and we have our domain x is greater than or equal to negative 3, with the interval being negative 3 to positive infinity. Inclusive of negative 3, we include negative 3. Our y values are greater than or equal to negative 4, and that interval would be negative 4 to infinity. The end behavior, we're going to the right, and we're going up, so that's positive, positive. And then obviously this function's increasing. So something that you may notice or may be curious about, set notation. Don't worry about the set piece. You can kind of ignore this squiggly bracket and then the line. We really just want you to write inequality notation for our class for Math 3, okay? All right. The next type of function that I'm going to introduce you to is the cube root function. Cube root function. So here is the cube root function. And the awesome thing about cube root functions is they go on forever. There are no domain restrictions. No domain restrictions. So why is that awesome, Mr. Schwarberg? Well, I will tell you why that's awesome. Because the domain is always, 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 always negative infinity to positive infinity. Always, for all of these. And guess what? The range, look, I don't have any discontinuities for our y values. We're going all the way from kind of over here. Again, that direction is always going to reach negative infinity. This direction over here, it's going up, so eventually it'll reach positive infinity. So our range is the same thing, negative infinity to positive infinity. And I guess here I should say no domain slash range restrictions. I'll include range in that. Okay, and then for inequality notation, I just need to write this as a compound inequality. We're starting at negative infinity. Our x values are in between. So negative infinity is less than x, which is less than infinity. And our inequality notation for range is the same thing. Negative infinity is less than y, which is less than infinity. Okay, so make sure you're using the appropriate variable there too for your notation. All right, now end behavior. Okay, I have two arrows. That means I have double the work. So I just have to go ahead and list both end behaviors. So as we go to the left, we're going down. Okay, so that's negative, negative. And then as we go to the right, our function is going up. So that's positive, positive. Okay, as x goes to negative infinity, g of x goes to negative infinity, negative, negative. And then our range as x goes to positive infinity, g of x goes to positive infinity. All right, there's end behavior. And then this function is always increasing too. So radical functions, they're either always increasing or they're always decreasing. They do not switch on you. Second example of a cube root function. A cube root function. How do I know it's a cube root function? Well, it has double end behaviors. And it looks like this sideways squiggly line. And that shouldn't be surprising. This is the inverse of a cubic function. Here's f of x equals x cubed. We graphed these earlier in the year. This is the inverse of a cubic function. F inverse equals the cubic root of x. So this is what we're looking at. And we'll graph these later on in the unit. But our domain, again, super, super easy. Negative infinity less than x less than positive infinity. And we can write that as set notation and interval notation. Sorry, inequality notation. You guys aren't doing set. And our range, negative infinity is less than y, which is less than positive infinity. And that's negative infinity to positive infinity. Easy, 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 easy points. Don't mess it up. End behavior. For this one, as we go to the left, our function's going up. Okay, so that's negative, positive. And then for the right side, our function's going down. Okay, so that's positive, negative. All right, so let's go ahead and list that. Okay, as x goes to negative infinity, that's to the left, our function is going down. G of x down. Did I say down? It's going up. Just testing you guys to make sure you're paying attention. All right, and then on the right side, as x goes to positive infinity, our function g of x is going down towards negative infinity. Okay, and then since our right side's going down, that's another way to tell this function's decreasing. Decreasing function. As we go left to right, decreasing. Okay, so those are my two examples for cube root functions. I have an example for you here. Pause the video, give this one a go, and I'll reveal the solutions here. All right, here are the solutions. Cube root function, domain and range, negative infinity to positive infinity, doesn't change. Our end behavior, similar to that last example that we had. On the left side, our function is going up. On the left side, the function is going up. So that is positive, negative. And then on the right side, our function's going down. Down. If my computer will let me write. So that is, oh, I flip-flopped them. This one is negative, positive. That's the left side. And then on the right side, it is positive, negative. Our right side's going down. Another question that comes up, does it matter which order, does this order matter in which I write these? Can I write the negative side first? I don't care. Either way is fine how you do it. You can flip-flop them. That's fine. Okay, and then this function's decreasing. It's going down. All right. One more example here I wanted to give you, just to give you a different look. Now, here I have a function. Is it a square root or a cube root function? Well, it has an endpoint, and it has only one arrow, so this is a square root function. Square root function. Our domain, well, this function starts at 3, negative 1. And our x values, if I was to make a list, here's 3. Our x values are getting smaller, or they're going off in the negative direction. They're decreasing. This is x. So our domain are the x values less than or equal to positive 3. And as an interval, this would be negative infinity to positive 3. including the 3. Our range for our y values. Well, our y values, the endpoint is at -1. And are our y values growing, or are they, kind of shrinking or going, growing in the negative direction? Well, looking at our y values, they're kind of going up. -1's the lowest value. So that would look like this. So this would be y values greater than or equal to -1. And as an interval, this would be -1 to infinity. All right, M behavior, the good thing is we only have 1. So on this one, the left side is going up. So this is going to be as x goes to -infinity, g of x goes to +infinity. Okay, left is negative, up is positive. And this function, we're going from left to right. It's going down from left to right. So this is a decreasing function. Decreasing function. Okay, I have a couple more examples here that I wanted to show you. Please pause the video and I'll show the solution here. Try this one. The domain and the range can be tricky for these next two, so give it a go. All right, here is the solution. Our x values are greater than or equal to 6. Here's 6, and our x values are going this way. And then our range, these are the y values. We're starting at 3, and we're going down. So y is less, did I say 3? 2. Y is less than or equal to 2. All right, and then here is the final practice problem I have for you. So please pause the video, try this example. All right, here is the solution. And again, our domain is x is less than or equal to -1. We start at -1, and the x values go in the negative direction. And then our range values also go in the negative direction. We start at 6, and we are less than or equal to 6. All right, before you go, I want you to go ahead and please reflect on this closure question. It says Peter and Damien have determined the domain and the range of a square root function shown in the graph. Is Peter correct? Is Damien correct? Or are they both wrong? Explain your reasoning. So go ahead and analyze Peter's answer, analyze Damien's answer, and then write a quick reflection. Please pause the video and I'll show you the answer here in a second. All right. Thank you for reflecting on the closure. In this case, both Peter and Damien are wrong, at least partly. Peter has the correct range, but his domain is incorrect. He flipped the inequality. And then Damien has the correct domain, but his range is incorrect. Okay, and then here in red is the correct domain and range. All right, thank you for watching this video. Please give me a thumbs up, like it, subscribe for some more awesome, wholesome math videos. All right, catch you next time. Peace.